Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105.
So this video is all about the tutorial for the chapter 8. So the chapter 8 entitled Subnetting IP Network. So designing, implementing, and managing an effective IP addressing plan ensure that networks can operate effectively and efficiently. So for them to operate effectively and efficiently or correct, so the IP address should be plan. So next one is the broadcast domain. So in any Ethernet LAN, devices use broadcast to locate other devices. So a device uses address resolution protocol or the ARP, which sends layer 2 broadcast to unknown IPv4 address on the local network to discover the associated MAC address. So these are the broadcast domain, and this one is the internet. Then the service a host typically acquires its IPv4 address configuration using the dynamic host configuration protocol, the DHCP, which sends broadcast to a local network to locate the DHCP server. So the octet boundaries. Every interface on a network is connected to a network. The IPv4 address and the subnet mask configured on the router interface are used to identify the specific broadcast domains. Recall that the prefix length and the subnet mask are different ways of identifying the network portion of an address. So these are the prefix length, the subnet mask, then subnet mask in binary. So just like they convert this one into binary, and this is the host, and the number of hosts is this one. So subnetting on the octet boundary. To understand how subnetting on the octet boundary can be useful, consider the following example. So assume that the enterprise has chosen the private address. So this one, subnet address, this one, then the host address, and these are the broadcast. So let's try this one. So the possible. classless subnetting. So, as shown in the figure, the slash 25 row borrowing 1 bit from the fourth octet creates two subnets supporting 126 hosts. So, these are this one, what it says. Then the second one is the slash 26 row borrowing. So, it's borrowing 2 bits to create the uh, 4 subnets supporting this one, 4 subnets to support the 62 hosts each. The next one is slash 27. It borrows 3 bits and then to create the 8 subnets uh, and support the 30 hosts. Then in slash 28, so it borrows 4 bits to create the 16 subnets and to support the 14 hosts. Then in slash 29, it has 5 borrowed bits to create the 32 subnets and support the six hosts, and then this one, the slash 30 has six uh, bits to create the 64 subnets and to support the two hosts. The subnetting formulas. So in subnetting, so it has a formula. So the 2 raised to n is equals to bits borrowed. So that's that. So this one, so it is 1 bit borrowed. So that's why it's 2 raised to 1. And 2 raised to 1 is 2. Then 2 raised to 2. So 2 bits borrowed. So that's why it's 2. So answer is 4. Then 3 bits borrowed is 8. Then 4 bits borrowed is 16. 5 bits borrowed is 32. And 6 bits borrowed is 64. So just like I said so a while ago, so the bits borrowed, then it is a 2 raised to n is the bits borrowed. So creating 4 subnets, uh, this one. Another, using the 2 raised to n formula for 2 borrowed bits, result in 2 raised to 2 equals to 4 subnets. So what you call the answer are the subnets. Creating 100 subnets with the slash 16 network. So this one. These are the 16 and you will borrow bits up to 14. So the last is from 2 raised to 1, just 2, up to 2 raised to 14, which is 16,384. Then creating 1000 subnets with slash 8 network. So we will use just a 6, we'll just borrow 10 bits. So from we'll borrow 1 bits first, then 2 raised to 1 is 2 up to 2 raised to 10. You will borrow 10 bits, so 1024. Subnetting based on host requirements. So there are two considerations when planning subnets. The number of host address required for each network, the number of individual subnets needed. So just like this one, so they borrow 1 bit, so 2 raised to 1 is 2, then 2 raised to 2 is 4, 2 raised to 3 is 8, and 2 raised to 4 is 16. Network requirement example. So these are the network portion, and this one are the host portion. The 172.16.0.0/22, then 10 host bits, so 2 raised to 10 minus 2 is equals to 1022 hosts. So 2 raised to 10 is equals to 1000 1024. So minus 2. So that's why it become 1022. Traditional subnetting based addresses. So building A, building B, C, and D. Subnetting portion. So these are the network portion and this one are the host portion. The variable length subnet mask. In all previous example of subnetting, notice that the same subnet mask was applied for all the subnets. This means that each subnet has the same number of available host address. Basic BLSM. So to better understand the VLSM process, go back to the previous example I shown. So this one. So subnet 7 will be subnetted further. So this one. Let's try with the figure 2. So it becomes here. So it becomes this one. So this next network portion, the host portion is this one, and the dotted. So they convert it into decimal, and this one became the decimal. So BLSM in practice, using the BLS subnet and the LAN1 segments can be addressed without unnecessary way. So these are the first. So they have all the same IP address and the subnet. So this one, then let's try with the figure. Then we will configure the router. Then they put the first is one. They put the IP addresses. So first is that 0. This one is 32, 64, and 98. So are the differences of them. The inter-serial interface, so this one is this one. So it has a subnet mask. Then number 3 is, so for this one, for building B. This one is for the building C, and this one is for the building D. Access to devices. So end user client, most network allocate addresses dynamically using dynamic host configuration protocol or the DHCP. This reduces the burden of network support staff and virtually eliminate entry errors. So they use the host devices are the .1, then the last one is the .229. The server is the first is 230, the last is 239. The printers .240, the last is 249. The intermediate devices that 250 and then the last is the .253 and the gateway is the first is 254 and it doesn't have a last here. So intermediary devices. These devices are assigned address for network management, monitoring, and for security. So that's the role of the intermediary devices. So management, monitoring, and security. The gateway, routers, and firewall devices have an IP address assigned to which serve as the default gateway for the host in that network. So the gateway is the IP address of the intermediate devices for the host networks to use it as the default gateway. The IPv6 subnet allocation with over 65,000 subnets to choose from, the task of the network administration become one of the assigning a logical scheme to address the network. As shown in the figure 1, the example topology will require subnets for each LAN as well as for the one link between the R1 and R2. So these are the example. So they are linked on each other. This one, the IPv4 subnet, so they subnet it. And then these are the IP address, IPv6 address. And then if they will configure. So the interface gigabit Ethernet, then the IPv6 address, and then they will exit. Then in 0/1 again, IP address, then exit. In the interface serial, then the IP address, then end. Chapter 8 is the process of segmenting a network by dividing it into multiple smaller networks spaces is called subnetting. So the chapter 8 is all about the subnetting. So such here, I will repeat that subnetting is a process of segmenting a network. So it is a segmenting a network by dividing it into multiple smaller networks. So that's all for this video. Thank you for watching.